We're live. Diego, we're live.
Okay, good morning, everyone. This is, as you can see on the screen, my name is Diego Lopez. I work for Telefonica and have been around. Probably some of you from may remember me from previous more physical editions of the Congress. I have been around for quite a while since we started working with NFV. And well, today I wanted to talk and to introduce things that are somehow related to NFV, but not, it's a consequence of NFV, but not the NFV technology itself. And it's, telling you about what are we doing and how we are addressing the idea of potentially using digital twins for enhancing network management and, for enhancing network management and taking advantage of technologies like artificial intelligence to better predict and control the network behavior. Basically, and this is based in something that probably some of you have heard about, which is this idea of a digital twin. That is, in general, a digital twin, and this is what you have on screen is a rather formal definition of what a digital twin is. It's a digital replica of real entities, and this is one important thing, because it's arguable that the network is a physical entity that support a seamless exchange of data and control between the real and the virtual world. So the idea is, comes from the manufacturing industry, where all this started, and the idea is that precisely you can rely on the digital twin to analyze what's going on, take decisions, and act on the on the real counterpart without having to offer some degree of experimentation, and when you are reasonably sure that the action is going to take or is going to have the specific effect. So some of the characteristics of the main elements that define a digital twin here is that, for sure, you have sensors and actuators. You can collect information. You can act on the real system. You need some degree of AI, because a digital twin is a representation of the virtual one. It's not completely or should not be completely equal. We will talk about this later. The possibility of interaction, and something that is very close to real time. The more real time, or the closer to real time, the better. Mechanisms for making a representation, so the humans behind it can understand what's going on, how it's going on, which are the effects, etc. For sure, you need a very strong trust when you want the digital twin to do something to the real or virtual, or physical twin. For sure, this has strong requirements on privacy and security, and what is important as well, especially in the network world, is that you have to abide by regulatory requirements. The point with networks and the application, digital twins have been around for a while. The point with networks is that networks are extremely complicated, and as I said before, you can think that the networks are not so physical to model, and the models behind networks are extremely, I would not say unpredictable, but really complex to grasp the whole and to model the whole complexity. There are things that you can think about. It's about this Metcalfe's law on that the value of the network is related to the square of the participants, or what I used to call the laser effects. That is how you accumulate effects that create much stronger effects as they align. Think about all the viral situation, etc. On the other hand, is that well, this complexity makes precisely the use of digital twins more and more appealing to network management. And think about how the coming generations, or well, the current 5G and the coming or foreseeable generations will add in terms of number of devices connected, in the density of these connections, etc., and how the network is evolving into something that, on the one hand, you have to deal with the demands of users, and on the other hand, with the most comfortable way of dealing with this is highly centralized environments, in which then guaranteeing openness, interoperability, etc., becomes more and more complicated. The curious thing is that, as you can see on the right-hand side of the slides, there is this, what I have called Borges' exactitude paradox. Jorge Luis Borges is an Argentinian writer that has very short, normally short tales, but they are very much focused on things that, I mean, they are tales that make you think, deeply think. And one of them is precisely about a story of an empire in which cartography became so much developed that they tried to build the perfect map. The problem is, at the end, the perfect map had to be drawn on top of the territory to make it perfect. So the idea is that we have to find a way in which we are able to build a digital twin without building a twin of the network, because the temptation is there and is quite strong if you think about it and say, well, no, what they need to have an impression and taking proper decisions, precisely this. For these, precisely things like software networks, NFV, SDN, etc., have been extremely helpful in providing us with the necessary abstractions of network elements to work with, and in having the necessary loops or conduits for feedback, for detection, fluctuation, etc. If we think about it, we have two, as we said before, we have two different flows. So the data flow, how you collect data from the real twin, and how you feed it inside the digital twin. The important thing here, and this is something that is essential when talking about this, is that no matter how intelligent the system is, no matter how much AI you put inside, if the data you get is not good, what you get is bad decisions by definition. And so there are certain properties of the data flow that we have to make. It's about this properly adapted, collecting enough data from the whole network. You have to be has to be assured that the data comes from issued and it comes at the appropriate time, and that is steady, that your AI, the system that is trying to figure out how your network is behaving in the digital twin doesn't go into starvation. We have been working on this, and what I'm going to introduce is a few projects, a few collaborative projects in which we are involved, in which we are analyzing this. And for example, in this case, it's about this 5G Clarity project, in which, among other things, we are considering or addressing somehow the mechanisms around the NWDAF in 3GPP, though we believe that we have to go beyond to do that. And this is something that we have addressed, precisely thinking in terms of this enhanced data fabric based on metadata. So the idea, and this is one of the goals that we are pursuing in 5G Clarity, is precisely to support the integration of different data flows from different parts of the networks provided by different services, and facilitating that we are dealing with heterogeneity, that data is properly adapted, aggregated, processed, or pre-processed before we deliver it to the AI in the digital twin. And this is equally important, it's not only about the data, it's about it's not only about the data on the network, but it's about the data on those data themselves, because that helps us in precisely in guaranteeing the properties around the trust we can put on the data, and guaranteeing that the data comes off at a steady pace. Other aspects is precisely the action flow. I mean, when the digital twin takes an action, it's something that can be complicated to translate that decision into something that actually or really goes onto the real twin. And this is something that is, I mean, it's more challenging even that the data flows. In the data flows, we are taking, I would say, first steps that are quite promising. Here we are still at the very beginning. But again, there are some initial strategies, like, for example, what we are doing in this project, in Inspire 5G Plus, which is about considering it for a domain specific. In this case, it's about security, mechanisms for recommendation systems, that at the end makes it that the actuator is a human, or something that is quite promising, that is the autonomic protocols that allow you only to deal with high-level policies that are translated into real action by the system that are autonomous to some extent. And to model this the same way that we are dealing with data models in the side of the data flows, we are considering precisely capability models and approaches based on service-based architecture approaches in the case to allow for understanding or abstracting and better understand the different actions that can be taken, and supporting precisely composition and combination of these actions. In particular, in Inspire 5G Plus, what we are doing is precisely trying to follow something that is a standard that is gaining more and more momentum, that is the architecture proposed by the ETSI group, the CSM ETSI group, and it's a zero touches network service management. And the idea is that you can coordinate it using precisely, as I said, a service-based architecture in which different domains of a set of operations that are consumed by the other domains using a loosely coupled interaction model based on what is called integration fabric. And what is important here, and is about precisely what I was mentioning about the autonomic protocols and the autonomy, is that normally when we're thinking in network environments, we're talking very much about orchestration as a central entity controlling how the whole network behaves as a set or as a single entity. Then here we should be talking more about choreography, in the sense that there is a common plan, but this is individually executed by each of the participants. Something that is important as well, and we should not forget, is that a digital twin or whatever other intelligence system has this closed loop that we have here in this basic illustration of the goals of automatics, but it has as well the input. The inputs provided by the controllers, by the humans, by the network administrators, whatever we call them, is the guiding for the whole system, how it has to behave. And the important thing here is that this input has to be at the high level, because otherwise doesn't make any sense if you had to go into that much in total detail. Again, we are facing this Borges paradox I was talking about. And well, normally in networking, this is referred precisely as intent, which is a common name that we are using for this high-level policy-like input provided by humans into a system that is somehow smart and is somehow controlling the behavior of the complex system. That includes that as well. In the case of intent, we need to agree, and this is something that is, there are some steps taken in the I would say, the right direction, in having a common base model, in developing the language and the expressions, in how they are interpreted, how, and this is it's extremely important, how conflict resolution can happen among intent that can be contradictory or associated with conflicting goals. And for sure, security, for security everywhere, you have to trust, you have to be sure that nothing leaks out, etc. And that is very much connected with something that is important as well. And this is one of the key goals of a digital twin, that is about intelligibility, that you can understand who did what and when, and what is even more important, the why. Why, if a decision was taken by the digital twin, something that is about something that is connected to what we were talking before about the representation, something that helps you understand why this decision was taken, and which were the policy rules that were applicable. In this sense, we are working again in another joint project that is called 5G Zorro, and 5G Zorro is about precisely, among other things, it's a common platform based on to support this intent based on the usage of shared and trustworthy data spaces in which you can define your intent, you can announce the possibility of acting on the intent, and all these the applicable decisions and the applicable policies are matched and verified. And what is important, let me insist, audit tracked using DLT mechanisms, so you can, third parties, yourself or other third parties, can verify that everything happened according to rules and can trace back the reasons for a particular action. And finally, let me, apart from these projects I was mentioning, let me introduce you something that is our particular project that we are trying to leverage with several of these joint projects, which is something that we call the Mouse World. The Mouse World is a project that we started a few years ago. Very much, originally it was very much focused on aspects related to security. The idea was to have controlled detonation of certain security threats and having an analysis and collecting data about this. Later on, we decided to move into making it suitable for generating data sets for training machine learning systems and validate AI models. But now we have realized that the principles that are related to that, everything is based on software networks that is model-based and that is highly configurable and allows us to perform simple reconfiguration, differential analysis, etc., is something that can constitute the core of the foundation of a future network digital twin, and we are working in that direction in our Mouse World. And still, there are aspects that we have to consider, like that you have there. Precisely, one is something that is crucial to consider. This real digital twin is about real-time management and direct control action. So it's about the real-time. What is, I would say, in conclusion, that is still focused on the. It is still the focus in which, or the direction in which we want to make the the Mouse World evolve in the future. And that's all. I hope I'm trying to leave a few minutes if you have any questions. Just as I remember, as something, a reminder. I remember some time ago when I started working on this, somebody compare all this that we are doing about with herding cats, which is something that is quite, I think it's quite accurate. And well, that's as I remember that herding twins is, it can be complicated. It's complicated, we are on it, but there are even worse things to do when you don't have the twin to help you. Thank you, and if you have any question, I'd be happy to address it.
Diego, we have one question. The question is from Robert Curran, and he says, your presentation focused on real time. Do you see a value for digital twin that model a view of the network that is further in the future, a day, a week, a month?
Sure, sure. And this is something that, I mean, it's true that I didn't mention the prediction idea for sure. And in both directions in time, I would say, is interesting a digital twin that helps you in predicting and taking corrective or predictive action of whatever the nature, for sure. And the other way around is something that an analysis of what happened in the past can help you in precisely planning for the future as well. Yes, yeah, definitely. I don't know. Anything else?
Diego, so have you overcome the key challenges, such as building the digital twin fast enough, dealing with complex systems or legacy systems?
Well, I think that precisely on this is what, as I said, when talking about the mass world, what we have found is that in general, if we are talking about the digital twin, not a complete representation, I mean, not the network itself, is something that dealing with this is something that can be done precisely relying on these software network technologies. You have VNFs, and this is something that you can make a very complex VNF, a very simple VNF that has equivalent behavior. And in the case of physical network functions on the physical devices and things that cannot be visualized by the Joule, we have very good models for simulation, emulation, etc. So it's something that I believe is doable, and our first results with the mouse world indicate so. And this is something that we are starting to work with as well, is precisely to collect direct traces from the network and injecting them in the environment. So I think it's doable. It's complex, and the important thing here is about having the proper abstractions and combining them or composing them in a way that is useful. There is the real challenge, let's say.
Thank you, Diego. And if anybody has any more questions to Diego, if you can put them in the chat box, I'm sure Diego will try to answer them in due course.
That's it.
Thank you very much, Diego.
Thank you. I will stop right